So this is a video about injective functions. So a function f from a set A to B is said to be injective if, so this is the definition, for all x and y in A, if f of x equals f of y, that will always imply that x equals y. And this means that if we take two different elements in the set A, the function f will map them to two different elements in the set B. So we never get a situation where we have two elements in A mapping to the same element in B. So this is not allowed for an injective function. So let's look at an example. So suppose we've got f mapping the reals to the reals given by the formula f of x equals 3x plus 1. Well, this is injective because if we take two different elements, potentially two different elements, x and y, in the domain, and we see what happens when we assume that f of x and f of y are the same. Well, that of course means by definition that 3x plus 1 is equal to 3y plus 1. And taking 1 away from both sides, divided by 3, that gives us x equals y. So the only solution here is x equals y. So by definition, this is an injective function. If we take an example, another function that isn't injective. So here's a function g defined on the integers, and it takes an even integer to n over 2 and an odd integer to n minus 1 over 2. So it's a well-defined function. Every integer has a unique image under g. But it's not injective. And that's because we can find two different values of n which map onto the same image point. So, for instance, g of 0, which by definition is 0, is also the same as g of 1. So we've got two different values in the domain mapping onto the same value in the codomain.